Can you record it? Okay,
Yes,
fine.
I started recording. So in this group, I'm sure there will be some people who would have had some background in analytics. And if ever you find that I'm speaking something wrong or something that is incomplete, you can probably raise your hand, and then we can start correcting or discussing from there. Even when I'm presenting, I'm just trying to go over the overview of things. So we keep it as generic as possible. And if you have any questions, you can just raise your hands, and we can stop me right there, and then we can probably have a few round of discussion, and then continue with the slides.
Yeah,
Okay.
you can tell there is a raise hand option.
Yeah, there is a raise hand option on your system. So if you probably down.
Yeah, it's in more. Yeah.
Yeah, it's in more. You can raise your hand, and I'll be able to see that. And even if you don't want to raise hand, you can just put a question in the chat message. And when I come across to seeing that chat message, I'll respond directly to that question. Right? Is this fine?
Yes, good.
Okay. So I'll start presenting my iPad screen, and then from there we'll. Okay. Are you able to see my screen?
Yes.
Okay, great. So we'll start with the most basic question. What do we mean by data analytics? And so this will be just like the base part where we start. So data analytics, we all must have heard a lot about this topic. Especially it's a buzzword now. There is no company or no big company that is at least not invested or interested or a prospective technology that they're working on to get into analytics, right? So what exactly is data analytics? So data analytics is the process of inspecting, cleaning, transforming, and modeling data to discover useful information to support decision making. Okay, so huge amounts of data is being collected, irrespective of which industry you're talking about. So whether it be an e-commerce website where you're collecting where is your traffic coming from, how many people are logging in, on what page they are on, whether it be in advertisement or banking or aerospace or any other industry. Data analytics is something that everyone is getting into, and the whole idea is once we are collecting lots of data, what do we do with that data? So analytics is the process of inspecting the data, finding out useful patterns in the data. Most of the data that we come across is not clean in the sense that it is noisy. It has a lot of missing values, and maybe the format that we are collecting the data in is not very friendly to machine learning algorithms. So we have to modify those data, clean that data. In many instances, we have to transform the data. So if you're collecting images, or if you're collecting sounds, or even website information, we cannot directly feed that data to learning algorithms. And there is a process where we convert that raw data into more useful format. And data analytics is also about modeling the data. So we will come across, and then the next big term we'll look into is machine learning, where we'll see that how we can model the data, how we can uh, represent the data into a function or an algorithm which can take the data and give us an output which is useful for us. So analytics is all about taking this data, and we want to discover useful information from this data that can help us to take decisions. So decisions as in where should my company invest next, or what will be my sales the next month, or what is going to happen in the future. And if we have a fair idea of what happened in the past based on the data we have, and we can predict what will happen in the future, then that gives us an edge over other companies. That gives us an edge which we can utilize to make more money, or we can utilize to probably invest in research. And what do we do with that is the second question. Okay, but at least the data helps us find out what has happened and what is going to happen. And that is just a rough overview of what data analytics is. It is a process of inspecting, cleansing, transforming, and modeling data to discover useful information and support. The next space we look into is, many of the times people get confused in what are these buzzwords, right? What is artificial intelligence? What is machine learning? What is data science? So this is probably a helpful diagram to explain where does it all stand. So we have a big circle of AI, which is your artificial intelligence, and AI has existed since a long time. From 1970s, 1980s, people have been working on neural networks, and even before we had this buzzword of data coming in, people have been working on AI. AI is basically having a program or having a computer which simulates a human action. Okay, so human action like thinking, or human action like planning, human action like identifying images or learning few things. It's a human action. And AI is basically artificial intelligence, where you have a computer program, where you have a computer which tries to simulate what a human would do. Okay? So there are many fields within AI. So if you look at this big circle AI, the yellow markers that we have, natural language processing, OCRs, optical character recognition, autonomous vehicles, robotics, image processing, planning, decision making, all of these have been AI concepts since a long time. Okay. Very recently, what has happened is, from the last 10 years or so, we are now also progressing into something called as machine learning. So if you look at this mixed kind of abstract shape in between, this is the shape that is representing ML, or machine learning. And what machine learning does is, we have algorithms or set of ideas which we represent mathematically, which can automatically learn something that can help into these areas. So when we talk about, let's say, natural language processing, so earlier when scientists or programmers used to program for natural language processing, is basically the field where, let's say, if you have text, lots of text data, can we understand the text? Can we answer based on the text? So something like what your Siri or your OK Google does, right? So Google Assistant, when you ask like, what is the time today, or give me the navigation to a certain address, what it does is it understands what you're speaking. Now, every time you speak, you may not use the same keywords. You may, mix and match. You may ask the question in a different format. And interestingly, the algorithm is able to understand what you're speaking. So as if it's like a human action. So does not need the same keywords all the time. You can change it a little bit, and still it is able to understand. So that
So
is
Elijah, this is this chatbots also is similar, right? NLP only, no?
Yes, chatbots are also NLP, where not every time you're asking the same keywords, but it is able to understand what you're asking, and based on that, it is able to respond to you. Okay, so it comes into the area of NLP. And what earlier used to happen is, people or whoever is programming these chatbots, whoever is programming these NLP, would identify rules manually. Okay, so they will say, okay, if you understand how the English language works, or if you understand how the Hindi language works, you will say, okay, this is a verb, this is a noun, this is how the question is formed, and they will give, okay, these are 10 examples of these questions, and based on those, they will formulate rules, and based on those rules, the algorithms or programs would work to answer the certain thing. Now with machine learning, what happens is, we don't need to, or we are coming into an area where we are not manually identifying those rules. Okay, we have an algorithm that learns from lots of data. So if you have lots and lots of data, your algorithm is able to pick up from that, identify the patterns, and from those patterns, learn how do you identify human language. Okay, so based on that, what is happening now is not only just in the field of natural language processing, but also in image processing or planning or decision making. Machine learning is coming into picture, where it uses data to learn what kind of patterns or what kind of features we need to implement for each of these applications. Within the machine learning space, we've got loads of algorithms. So I've written some algorithms here. So we've got logistic regression, we've got ridge, naive Bayes, reinforcement learning, decision trees, neural networks, lasso. So as we go next, I will explain basically in what categories our classification or machine learning is classified, and where do we see that space. But in general, machine learning is a subset of AI, where it is empowering each of the different main applications of AI to work autonomously or to work independently. Okay, and the power that it gets from is it gets its power from the data. Okay, where we are trying to find patterns within the data, learn ideas from the data itself, which can what do you say, enhance our output. Okay, or it can reduce our human work as well. So within this whole space of AI and ML, you see this overlapping circle of data science, right? So Now it is not clearly defined, and you go to 5 different websites, and they will define AI separately, they'll define ML separately, they'll define data science separately. So even within the industry of data scientists, it is not a very clearly defined thing. But in general, this is what data science means. Okay, so it is overlap between AI and machine learning, and also something that is not AI and machine learning, so something from outside. Okay, data science is basically this field which involves maths and statistics and visualization tools, where it can take up huge amounts of data and do analysis on that data. Okay. So when that analysis is just manual, when that analysis does not involve machine learning, you come outside of this space. Okay. So there are a lot of things within data science that you can do without the machine learning aspect of it. Okay, so you can do visualization. So visualization or descriptive analytics is basically taking huge amounts of data and representing it into a format which can give us more insights into what has happened in the past. Okay, so we have from the statistics background, we have distributions and probability distributions. What do you mean by statistical inference, sampling, A/B testing? So all of these ideas are outside the ML space. Okay, and within outside the ML space, you can do a lot of things with data. But the big power of data comes in, or data analytics comes in, when you try to incorporate ML methods and AI methods into our data analytics field. So that is where what we can do is we can take old data, identify patterns, and create models which will be able to predict what will happen in the future. Okay, and that is what is interesting. So of course, it is of value to understand what has happened in the past. But for companies, if I know what is going to happen in the future, I can use that information for making, for planning or making business decisions that will profit me in the future. Or if I know what is going to be the sales for the next year, I can probably stock up items, increase my logistics, do other things that can aid in improving that space. Okay, so that is what this space is. Now, within this space, we've got different job roles. We've got job roles of a data analyst, of a data engineer, of a data scientist. And these are actually progressive roles where when you start from analysis to engineer to scientist, you are moving into the space of going more towards machine learning. Okay. So data analysis is someone who primarily deals with huge amounts of data, trying to clean the data, trying to integrate the data, trying to do visualizations of the data, trying to tell a story out of the data, where you explain basically what has happened in the past. Okay, data engineer is someone who works with the entire data space. Okay, from extracting data from different sources, writing pipelines that will take that data and put it into a structured format, cleansing the data, interpreting the data, probably even modeling the data with ML methods to be able to predict what is going to happen in the future. A data scientist is someone who also, it has a huge overlap with the data engineer's role, where you're doing all of what the data engineer is doing. Additionally, you're deep into machine learning now. You're deep into machine learning in the sense what you're identifying predictive models for classification and regression. You're identifying deep learning methods which will be able to model the data and predict what is going to happen next. Okay. Do you have any questions before we move ahead?
Elijah,
yeah, go ahead.
So machine learning is the driving force of AI. That's what you meant to say.
Yes, machine learning is the driving force of AI. So AI is yeah. Go on.
Deep learning.
Yeah, I will talk about deep learning in the slides to come. So deep learning is again it's a classification within the machine learning space.
Okay, thanks.
Luke, you were also asking something.
Is this ETL? Is it that extract transform load?
Yes. ETL is extract transform load, where you
see there also actually people take data from a larger what do you call source. They make some transformation logic and they load it to different tables, right? And you generate reports out of it to just make some. So how that is different from the other one? Because decision making there also it's possible, right? Or it's like it is a very macro level decision which you take there.
So ETL primarily is basically when you have data in different places. So let's say for a website, you would have data from, let's say for a bank, you would have transaction records, you would have your customer records, you would have loan records and how often people have visited the bank. So these are different kinds of information. And to be able to do analysis on different kinds of information is probably difficult. So what we do is ETL is the process of taking these different sources of data and putting it into a data warehouse. So in a data warehouse, it is structured data. You can connect your Tableau or something there, which you will be able to see insights into the data. So ETL is just the process of taking raw data or taking data from different sources, transforming it a bit, transforming it in the sense, generally we don't do a lot of transforming here. We do majorly transforming is cleansing the data or removing certain outliers and putting it into a structured format.
Okay.
Once it is in the structured format, the next process of analyzing that data starts. So ETL does not necessarily include analyzing also.
Okay.
It is just collecting the data and putting it in one space.
Okay. So Tableau, whether you mentioned Tableau. So Tableau is it's a
Tableau is a tool.
data science tool, right? No.
Yes, it is a data visualization.
Okay.
Where when you can when data, all of the data is in one space, you can see them together, see patterns, see graphs, which your management and other people, when they observe those graphs, they can take insights into what the data is trying to do.
Elijah, you mentioned this ETL in this data science section. It can be done for ML purpose also, right, or AI purpose also.
Right. So the purpose may be depending upon the application, but specifically for implementing ETL, I am not using any ML methods, or primarily people don't use ML methods. ML methods can be used for outlier detection and things like that, but ETL is mostly programmatic. I am not sure, or at least I'm not aware of people using a lot of ML methods within the ETL space. ETL is just extract, transform, and load. So
ETL generally, I know people just take data, they cleanse the data, and they write very complex queries and upload data into a specific format which makes sense for a data warehousing purpose.
Right.
So it is like as he said, it's like a raw data into a transform data where you actually can work on top of that. So it's just a pretty much a preliminary step in the whole process of machine learning. That's what I understood.
So when I talk about ML, I'll basically go into what do we mean by ML. Okay, so ML is,
What is the full form of ETL?
ETL is extract, transform, and load.
I think, Elijah, what Amit is also saying is, as part of ML, when you're writing a code for any algorithm, you also do some transformation and all of that. So there also partial ETL happens. But here what he mentioned, I think, is more a processed thing, which comes even before you start your data science or kind of thing, right?
Yes, that's right. That's right. So yes, even with ML, you would be doing some kind of transforming and things like that, of course. But ETL is specifically just meant for this task. Okay, should I go ahead?
Yeah, please.
Yes.
So there's a growing need for analytics, and of course that is primarily one of the reasons we are having this discussion, where we know that how important analytics is, and a few reasons why it is so is because now we have a generation of large amounts of data. You talk any space of industry that we're working in, everyone is collecting huge amounts of data. Firstly, because it is much cheaper to do it now. It is much more accessible. Along with that, we have also availability to store large amounts of data at very low costs. So I remember a time where storing data online was probably, I think Google, when it started, it was giving me like 2 GB space. But now my present capacity is 15 GBs. Dropboxes are in 15 GBs and so on. So even within personal space or commercial space, storing huge amounts of data has become very cheap right now. Okay, this is because of advances in probably how we create data, how we store data, and along with that, an additional feature is we also have now tools and technology to analyze huge amounts of data. Once we have that data, we have the methods, we have the tools, we have the languages where we can take all of that data and do analysis on it. Primarily, data without the analysis is majorly useless. Okay, I can give you huge amounts of raw data, and we cannot it will be very difficult to get insights from that unless we do certain analysis that is transform it into a space which can give us business insights. It can give us other things. Because of this, because of huge amounts of data, because of being able to store lots of data, because of having the right tools and technology that can help us analyze data, now we are into the space where everyone, or whether you want to take precise business insights or you want to recognize sales and market opportunities, uh, the top priority of a lot of organizations is getting into this field. So if you look year on year, the kinds of jobs the number of jobs within this space, it is increasing every time. So even CAGR, the rate at which is increasing is around 13 to 15 to 20%. Every year, lots of different companies who are not already into analytics are getting into analytics. Okay? It's simply not an option for any major company to not enter into this field, which basically means that lots of jobs throughout the spectrum, from the jobs of an analyst to an engineer to a data scientist, huge amounts of jobs are opening up within this space. When we look at the key type of analytics that is present, we can further divide it into three parts. We can talk about something called as descriptive analytics, predictive analytics, and prescriptive analytics. So even in my even in my talk of talking about data science, I use these terms. We'll probably go deeper into what do they mean. So descriptive analytics is basically saying that if I have the data and I do some graphs and plots and visualizations on the data, I try to identify what has happened in the past. Okay, and this is like a test report which helps me find out, generally descriptive analytics also results into dashboards, which helps us find out what has happened in the past. Once we know what has happened in the past, we can probably see how well we are doing, how bad we are doing, and based on that, try to take the next steps. Okay. That is one major area of analytics. The next major area of analytics is predictive analytics, where we will predict what will happen in the future. So this happens by modeling the data, by forecasting, by identifying what is the likelihood of the next thing happening, doing further analysis on the data. We'll try to find out what will happen in the future. So once you know what will happen in the future, you can take possible decisions. You can change your plans. You can modify those plans. You can enter into new areas and things like that. Prescriptive analytics is once you know what will happen, what is the best possible thing that you can do. Okay, so once you know what is going to happen, you can take, let's say, 5 paths. Out of those 5 paths, each of those paths will give you what kind of output. Okay, and that is where you go into prescriptive analytics, where it basically depends upon what are the rules, what are the processes, what are the boundaries, how much revenue can you make, how much does it cost, and things like that. So maybe if I have to give an example, let's say we take example of the stock market, and if I just take the prices of the different companies, what they have done in different stocks, and I just plot those together, I can see how they have done in the past. Okay, so at what rate, where did they start, where did the different stocks have a dip, how are they increasing, what is the rate of interest, or at what rate they are increasing, and things like that. So just plotting that information or seeing what has happened in the past, writing some numbers down, that would be something like descriptive analytics, or that would be categorized as descriptive analytics. Predictive analytics would be the part where now, let's say you have old data, you have lots of data for different companies, you know what has happened in the past. Can you predict what is going to happen in the next day or in the next month or in the next year? Okay, so that would be predictive analytics. Based on the past data, we are trying to learn a model that will be able to predict what is going to happen next, and that is pretty. And this is very useful because if you know, let's say if I know tomorrow what is going to be the price of a particular stock, I can put all my funds there. If it's going to fall or going to rise, based on that, I can allocate funds, which will help me make more money out of it. Okay, so that is where you say predictive analytics would come. Prescriptive analytics would be, let's say you know what is going to happen. You know what is going to happen for like 10 different stocks. How do you allocate your funds? Okay, what are the risks you take? Now these risks would be different for different people, depending on my age, depending on what is my risk capacity. I would have different percentages of allocations and things like that. Prescriptive analytics would say, like, given this prediction, okay, what is the best thing I can do? Okay, and doing that thing will give me what kind of output. So that is probably the next layer of analytics that we do. Most of the industry has already been into descriptive analytics, where we are already doing, we are seeing what has happened in the past. Many of the companies have moved into predictive analytics, where we are also trying to predict what is going to happen next, and based on that, do make certain decisions. And very few companies, so this is probably our goal, where we are moving into prescriptive analytics. Once we know what is going to happen, and this what is going to happen always comes with a certain amount of uncertainty, so that it comes with a band on what is going to happen. So based on this band, based on this uncertainty, based on my individual capacities and where my company is positioned right now, what is the thing to be done? It comes under prescriptive analytics. Right? Is this fine? Have you got this?
Yes.
Yeah, go ahead.
Yeah. Okay. So let's talk about machine learning. Machine learning is basically the task where we have, let's say, data, and this data can be different kinds of data. Not it can be text, it can be images, it can be sound recordings, it can be Excel sheets, it can be databases. So once we have lots of data, what we are trying to do in machine learning is we are trying to learn a task. Okay, a task can be something like okay. I put up examples here also. So let's say I have data, I have financial records. The task in the machine learning program could be something like this: should the bank approve a loan or not? And that's a task that can have an answer yes or no. Okay, and for this task, for these tasks, we have a measure like accuracy. Okay, so in the past, approving a loan to someone, has it been beneficial or not, or has the bank approved it or not? And that would be the measure. The machine learning part is basically taking the data to learn a task so that this task does good on the measure. Okay, so we have these three things: the data, the task, and the measure. Okay, we're learning a task that will continuously perform better and better on the measure part, and to do that, it is taking help from the data. Okay, so certain examples are, let's say I have financial records and we are doing the task of approving or not a loan, and the measure is accuracy. So accuracy is, in the past, have we approved these loans or not? And are we able to learn an algorithm that is just able to take the data and learn to answer the question whether to approve or not a loan? Okay. Or let's say we have a different example where we have, for a house, we have the square foot area, we have the number of rooms, we have what is the garage size or information regarding the garage. And using this information regarding a house, regarding real estate, are we able to predict what is the price of the house? Okay. So using lots of old data, are we able to predict what is the price of the house, and how do we measure if the price of the house is right or not? So on this data, I have past records, and for these past records, I can see what is my prediction, what is my past record, and what is the mean squared error between these two items. Okay, so more the error means my prediction is bad, less the error means my prediction is good. Okay, so measure is something that helps us identify if this task is doing good or not. Okay, so for every
Elijah.
machine, yes.
Yeah, Elijah. So the measure is defined by your the previous data, right? Whatever is there.
Yes, yes. So in this case, there are different examples. At least in the first and second example, we are defining the measure based on the previous data. The previous data, if I know the loan was approved or not, I can test if my model now is telling approve or not. And based on how accurate my model is compared to my data, that is the measure in this example one. In example two also, my prediction now is not a categorical, means it is not yes or no, but it is actually a price. Okay, so when I want to compare what my model has given as the price and what is my old price, I will now find out what is the error. So there are different ways of identifying error. One way of identifying error is, let's say my model says the price of the house should be 1 lakh. Okay, and my data said it should be 1.2 lakhs. Okay, so my error is 20,000, and let's say I'm doing this for 100 different samples. I will take all of these errors, I will square them and find. So I'll have the mean squared error. So how do I know if my task is improving? So over a period of training, my mean squared error will go on reducing. If my mean square error goes on reducing, I know that my task is now learning. My task is becoming better and better. So
Okay, so it'll continuously will change that mean square error, a
yes,
particular
yes,
value.
yes. As we are in the process of training, our task will become better and better on this measure, and or that is the way we know that our machine is learning. Okay.
Yeah.
So all these four examples are actually showing different ideas. In the first case, we're talking about accuracy, where we're talking about a category, whether my task is giving a yes or no answer. Whereas in the second case, my task is giving a number, and we are trying to see how close is that number to my actual data. Okay, let's look at this third example. In this third example, we are trying to train a vehicle to drive. Okay, how do I train a vehicle to drive? So for this, the data would be to observe human drivers. Okay, so if my algorithm is continuously observing, what does a human driver do? Where does he change the accelerator? Given the present road scenarios, do I change the gear or not? Do I change my steering? Increase the speed, brake, and so on. So this would be the data. The task would be to drive a vehicle, and here the measure would be the goals. So goals could be something like, am I able to reach? How fast am I able to reach my distance? How fast am I able to cover my distance? Or how safe is it? Or am I breaking any rules while doing that? So that would be the measure here. So in this case, the task of machine learning would be to take this to see how humans have been driving, to learn how to drive, so that we are meeting all of our goals. Okay. In the fourth example, we have, let's say, this is a task of recommending a next movie. So let's say you have an account on Netflix or Amazon Prime Video, and you have been watching certain set of movies in the past. So Amazon or Netflix would probably tell you what should be the next thing you should watch. And the way it would do that is it would observe what have other users done. Okay, so there are lots of users on Amazon, or there's lots of users on Netflix. They will see people with the same taste in movies. What have they seen next? And based on what have they seen next, using that data, we'll try to predict for you what is the next recommended movie. That is the task that you're trying to learn. What is the next recommended movie? And based on similarity, you would measure this like, okay, how close is this recommendation based on other users? And that would be the measure here. So in general, machine learning is basically taking data. This data can be in different forms to learn a task. These tasks can be of different kinds. In this case, this is a categorical task. In this case, this is a continuous variable you're trying to predict. In this case, you're trying to drive. In this case, you're recommending a movie. These are different tasks that you can learn from. Okay. So from this data, we're trying to learn these tasks so that the task is performing better and better on these different measures. Right? Does that make sense?
So Elijah, this measure you have mentioned, right?
Yes.
So it's a way to validate your ML program, right?
Yes, it's a way to validate your ML program. Right?
And once only the measure gives a good result, only we can finally implement. For example, in the driving vehicle scenario, we cannot fully implement that ML unless the goals are met consistently with respect, right?
Exactly.
So this is just a way to maturing your program using the measures.
Yes. So the thing is that even the task of learning from the data. So even this process, when you're improving from the data, how do we know that the method is learning? Okay. So we need to have, even in the learning phase, I need to have a measure which tells me, okay, can you mute?
Pastor Luke, can you mute everyone?
Okay. So even during the learning phase, when we are taking the data and learning, at every step, I need some confirmation if I have learned something or not. So that confirmation happens with the measure. So of course, the measure is also an endpoint measure where, before deploying, I will see if my method is doing good or not. But much before that, even before we talk about deploying the model, even during the learning phase, at every step, we need to have some feedback into this task is being improved or not. Okay, and even for that part, we need the measure. So without the measure, it's not just an endpoint. It is also during the learning phase when we do this.
Robin, just to clarify your point, so you actually cannot have 100% everything working before you can actually implement. So what I understand also is any type of such programs, it goes through the learning process. The learning process can be some simulated data or live data. So over a period of time, it becomes perfected. I think that's why they call it as machine learning. It learns and corrects by itself.
Okay. Yes. So now, when we look at machine learning, we can divide the space into multiple parts. So when we classify how does what does the machine learning space look like? So the machine learning space can be further, say, classified into supervised learning, unsupervised learning, reinforcement learning. Okay. So supervised learning is basically when I have data for which I know what the correct output should be. Okay. So in our case of this example where we talked about loan prediction, when we are trying to learn this task of predicting a loan or not, I have the past data which tells me in the past whether the loan was approved or not. Okay, so that is, I know what the answer should be, and for future cases I'm trying to learn a model. That is somewhere we call as a supervised learning, where I previously know what the answer is. Even for predicting the house price of a house, I previously know what was the prediction of the house. I know what is the price of the house, and I'm trying to learn a model which will be able to predict for future scenarios what will be the price of a house. So in supervised learning, we are coming across with data where we already have the labels. Okay. Whereas in unsupervised learning, I don't really know what is the right answer for the data. Okay. What I'm trying to do is I'm trying to get insights from the data. What is the data trying to tell me? Okay. I don't know what the answer is. I'm not learning to predict something that has happened in the past in the future, but I'm trying to find out new patterns within the data. So this would be like clustering, anomaly detection, things like that. So this is unsupervised learning where my data does not have a label. Okay. My data is free of labels, and we are trying to find out what we can do with this data. Reinforcement learning is a different kind of machine learning where I don't necessarily talk about data being my source. So I'm not necessarily learning from data. Here we have an agent. So it's a robot or a program of some kind, which is allowed to do certain actions. Okay. And whenever it does certain actions, uh, it is interacting with the environment. And based on its interaction with the environment can give some feedback to the agent. And on that it is learning. Okay. So we have supervised, unsupervised, and reinforcement. Supervised is where we don't have labeled data, or supervised is where I have labeled data. I know what is the right answer. Unsupervised is when I don't have labeled data. I don't know what is the right answer. I'm trying to get new insights from the data. Reinforcement learning is where I'm trying to train a model, trying to train an agent to do something by interacting with the environment. Now, when we look at supervised learning, where I have data, I can divide supervised learning into two parts. Okay, so I can have a classification problem or I can have a regression problem. A classification problem is basically trying to categorize my three different, categorize what my data should be classified as. So in a loan example, it should be classified as approve the loan or reject the loan. Okay, so there can be different examples of this where primarily classification represents that my answer, my label is a categorical number. Categorical number means it's a category, class 1, 2, 3, class medium, high, low. What is the so whether I go to play or not. So that would be question. So binary information like this, or so categorical information is something. Am I being clear in this? Are you getting what I'm trying to say here? If my prediction can be divided into a fixed number of classes, that is what I talk about classification kind of problem. In contrast to that, a regression problem would be that we are trying to predict some continuous variable. Okay, so my target variable is a continuous variable. In the case of predicting house prices, I'm trying to predict what is the sale price. Okay, so that sale price cannot be categorized as the sale price is 500 or 5 lakhs, 10 lakhs, 15 lakhs. Whereas it is a continuous number, and depending on what my data is representing, I'm trying to learn a model which for new data I'll be able to predict what is the exact price at that point. Okay. So this is under supervised learning where I have labeled data. That labeled data can be in the form of categories or it can be a continuous variable. If it is in the form of categories, the kind of machine learning algorithms I'm learning is called as classification. If it is in the kind of continuous variable, the kind of machine learning algorithms we're learning is regression. Okay. Do you have any questions in this part?
I have a question in supervised and unsupervised learning.
Yes.
So when under supervised classification, when we are training the model, that time we get a certain result. And when we are testing that same model, we are able to modify based on the results, right?
Okay, right.
Right?
Yeah, yeah.
Then in unsupervised learning, how will we be able to better our model if we are not having any supervision over it?
Right. So yes. So unsupervised learning is also, let's say the class of the case of putting into categories. since I know for supervised learning what the old categories are, I can verify here if my model is doing good or not. Right? Whereas for this kind of task, unsupervised learning, where I don't have a y-axis or I don't have what is the target, we are trying to cluster. Now, this clustering is not, like say, it is not unanimous. If I give 3 different scientists the task of clustering, they may cluster it differently. Okay, and they would cluster it differently based on what are the end goals. Okay, the end goals of it. So let's take an example. I'm a t-shirt company, and I want to divide my t-shirts into a small size, medium size, and large size. Okay. The question is, how do I define what is small size? How do I define what is medium size? And how do I define what is large size? So what I'll do is I will probably see a record of all people wearing t-shirts. I will have a record of people with different heights and different, what is their body structure, what is their shoulder width, what is their waist, and so on. And based on that, I'll plot all of my data. Okay. Once I plot all of my data, can I see a pattern where within some range I have, okay, let's say within some range I say that, okay, all of this data seems to form a cluster like this. All of this data seems to form a cluster like this. All of this data seems to form a cluster like this. So the generic clusters that I see within the data, from that itself, I'll be able to say if my target is three categories, small, medium, and large, and my data also looks in 3 categories, then my answer is simple. I will divide into 3 clusters. But let's say my data looks like 2 clusters only, and I still want 3 categories. Then I will go back and ask the question to my company that do we actually need 3 categories? Because when we look at the data looks like it neatly forms into 2 clusters. You see, so here even the number of clusters or how do we classify into clusters is very specific to what my company is trying to do. Okay. Whereas for classification, for supervised learning, I already know the answer. It is very easy for me to distinguish between categories. For unsupervised learning, it all depends upon the different objectives. Okay. Maybe my company does not. It wants to have a difference. It needs to have all t-shirts of just one size because that is where most of the market is. Or if I see that my market is diverging, I want to have 2 different sizes. So the answer here for clustering is not very generic. No one can say that this is the right answer or not. It all depends on case-to-case basis. Does that help you?
Yeah.
Are there any measures based on which we can say our model is doing better or no?
For unsupervised learning?
Yeah.
So there are measures. So let's say for clustering,
is there any example in a previous slide showing unsupervised learning? For example, driving the car comes under unsupervised?
No, driving the car comes under reinforcement learning. Actually, it could come in supervised or reinforcement depending upon how we are stating the problem. But driving the car is not unsupervised. Unsupervised learning is basically trying to find inherent clusters within the data. So as sister was asking, what are the measures that we can identify? So we let's say there's an algorithm called as k-means algorithm, where we try to identify what are the different clusters that it forms into. We use methods like elbow method and things like that. But again, what I have seen in my experience is as clearly we can define for supervised learning whether something is good or not. For unsupervised learning, that decision is not very clear. It is very subjective to whatever task you're doing, and it depends from industry to industry. We have methods, of course, we have methods where we can compare between 2 algorithms if they are doing good or not. But objectively, like in the whole big scheme, in absolute terms, it is very difficult to say whether you have the right answer or not.
Yeah, and also I think the validation happens over time, where once you group and then you test it, and then when you put it into practice, you see the results if it's working or not working, and that's how we take a decision.
Yes.
This was a follow-up of what Angel probably asked. Is that right, Angel?
Yeah, kind of.
Yeah.
But we cannot still have a quantitative validation, right, with unsupervised, like as we do for the supervised.
There are methods, but throughout people are still there is no unanimous that okay that this is the measure that we'll use for unsupervised learning. It always works on a case-to-case basis. Or maybe I have some material later on. I can forward you some material that can
I think
probably help you in
no,
answering.
Elijah, as you rightly pointed, all those things, there are a lot of variables.
Right.
So there is no one way of doing it because it's again industry dependent, or it's all very subjective to a lot of things. So probably, is there any industry standards? Nothing like that, right? It's basically it's a evolving thing, right?
Yes, different industries will have different standards.
Yeah.
So Satyendra brother is raising his hand. Do
Hi.
you have a question, Satyendra brother?
Yes, brother. These three techniques, these three methods, which one we can prefer for if you want accurate results? Like, is it still subjective to the industry, or if we want to, let's say, automotive, which technique can I?
So the technique actually depends upon what kind of data you have and what is your objective. Okay, so we can
Want accurate results?
yes no we cannot. So before looking at the data, before looking at the question, we cannot choose any method that will always work. All of these different methods have different purposes and goals. Okay, and it depends upon my data also. Let's say if I don't have labeled data, okay, then I cannot use supervised learning. So all of this goes in the drain. I cannot use this methods. So it depends upon what data we have. So even for the automotive industry, your machine learning problem can be of several parts. Okay, so let's say your machine learning problem is this: I have 5 motors. Which of these motors will work good for my vehicle? Okay, if I'm trying to drive an electric vehicle. So depending on the question, so that could be a question. Another question would be, how do I train a model to drive autonomous vehicle? Or for how do I do temperature control and AC? So each of these are different kinds of questions we are asking within the automotive industry. And each of those questions would, the way you'll answer them is, what kind of data do I have? What is my end goal? And based on that, you will try to see what algorithm works well. Does that probably answer your question?
Yeah, yes. But and can we cap some boundaries on this data? So, I mean, what
Boundary
I
as in how much data is
hopefully,
enough?
yeah, they are like upper and lower bounds. Does it help in these three techniques? The data is there. Like, can search be within these ranges?
Okay.
Like you're saying, temperature is there between upper and lower bounds. I need some optimum value.
So,
Then
are you asking a question that?
supervised? Yeah. The answer is question, but if I want to choose this reinforcement learning, which is based, like you said, there is a reward punishment.
Yes.
You said.
So I'll give you probably more example on reinforcement learning. So reinforcement learning is all what machine learning is doing is basically trying to see humans and how would humans react in different ways. How are humans learning? And all of these different algorithms in different ways are basically trying to see how humans are learning and can I take the same idea and implement into a program. Okay. So within that same category, reinforcement learning is, let's say, how does a child learn to walk? Okay. So it is very difficult for us to teach a child to walk. What would happen is the child would interact with the environment. It will say, okay, I want to move from one place to the other place. So it will start by crawling. It will start by walking on your knees. It will start experimenting different things. And every time it experiments, it gets a reward or a punishment. So a punishment would be like falling down or not reaching quickly. A reward would be being able to reach quickly to the destination. So over a period of time, just by interacting with the environment, the child learns how to go from crawling to crawling on your belly to walking to walking on your knees, then probably learning up to stand, learning to balance. So all of it learns is by interacting with the environment. Okay. So here what we do is, even for a machine learning, we would say, let's say if my task is learning how to drive a vehicle, I would give the basic tools to the algorithm. So tools like this is how you change the steering wheel. This is how you change that, press the accelerator, brake, or this is how you increase the gear. So just with those tools, you will leave it open to interact with the environment, of course, in a safe manner. So this could be a computer simulation. So in the safe manner, it is interacting with the environment where it gets rewards. So rewards is if it is able to reach its destination or it is able to get closer to its destination. A punishment would be probably breaking the rules or not reaching as quickly or doing something like that. So over a period of time, this
Yes.
agent is learning what on the actions when it is supposed to take an action depending upon what it sees on the road. Okay, and this allows it to learn over a period of time. So this here we are not providing with loads of data. We are actually providing means of interacting with the environment and means of getting reward and punishment. And based on that, the learning is happening. Whereas all the other cases we require previous data. Here we require labeled data. Here we require unlabeled data. Here we just provide means of interacting. So all of these comes under machine learning, where you're trying to learn something, trying to learn something without specifically being programmed for it.
Okay.
Okay. So let us go to the next part. Okay. So this is what Robin was asking earlier. What is deep learning?
Elijah, I have a question.
Yes, sure.
Yeah. So to go to the previous slide. Yeah. Like Amazon and Flipkart is like online shopping platform. So they will be giving us recommendation. So this pattern of shopping behavior is kind of supervised machine learning, right?
No, actually, then I have missed one more part because I can categorize into one more field called as recommender systems. And what you are saying would come under that recommender systems.
Okay. Okay. So but like even not only recommendation, you are going for electronics goods, they will be showing you all the electronic items like mobile phones. So they already have a set of classification, right, in their like cloud or in their program, so that when you are searching it like electronic goods, they can completely show you all the classification from their cloud-based server. So just like that, sports goods, then domestic goods, households, all this they already have classified, right? That's why I just asked, like maybe they have a supervised machine learning system.
Elijah,
I think
to add to that,
Mhm.
you remember you talked about that descriptive, predictive, and prescriptive.
Yes.
So does that come under the prescriptive category where they have learned the behavior of users and they are recommending it? Is it like that?
I'm not sure.
Okay.
So I'm not sure how they are putting up what to put.
Because
So I'm guessing that would.
Yeah, anything you search, it just comes up on FB or anything, whatever you search before. It will start scrolling
So
up on your. Yeah.
Since we don't know how exactly what is the internal working, we could only guess how they would work. Okay. So what I would think is probably it may, for doing something like this, we may not even require a machine learning model. I can just look at the past data, how well it is going on, and maybe I can manually also decide what should be the next product to recommend. Okay. Just by seeing which ones are doing good, I'll put it in that order. Or I can even have a machine learning algorithm that can rank the products based on their sales, and based on their sales I can take the top 10 products, or my first page will have the top 25 results, next page would have next 25 results, and so uh, will it actually be a machine learning problem or not? I am not sure. Monica sister, can you answer this?
Sorry, I did not follow the question. Could you just repeat the question?
So the question was, let's say on a website like Amazon or Flipkart, so when you search for a mobile phone, how do you decide which results will come to you? Is what kind of algorithm would be running in the background to be able to give those results?
It is again on the sales promotion, no?
No, it should be recommendation systems.
Yeah, it should be recommended.
Yeah.
Okay.
So again, since it is happening in the background, it is very difficult for us to be on the user end and try to estimate what is happening. It could also be a series of different algorithms that could be working together to be able to give a voter kind of system.
Okay.
Yeah, it's always probably not just one algorithm which runs. It will be a combination, which they'll use the output of one algorithm and then include it in another, and then get the final results.
So basically, they are learning the patterns of human browsing, right? Whatever they search, all those things, right?
Yeah, the shopping history.
So basically, it is like it is not a unsupervised data or a reinforcement. I think it's pretty much everything is categorized there. It's pretty much they are taking the data and making a prediction. And probably if it's a sales promotion, they put their own strategies within the algorithm so that it just give those recommended products. I'm just guessing, so I may be wrong.
Right. So at this point, it is very difficult for us to say what. There can be multiple solutions to the same problem, and what one company chooses may not be the same solution other company would choose. It would depend upon so many things. Okay. Uh, can I go ahead to deep learning? Okay. So the whole task of basically taking data and trying to have a model that will do better on a task. So if you remember, we talked about data, task, and measurement. So the process here is from this raw data, we are trying to learn certain features that helps the model to do better. So either this feature learning is part of the model, or it is something that humans do earlier with the data to process it into a format that is usable. Whatever we do with that raw data is called as feature learning. Okay? So feature learning is basically taking raw data and identifying patterns within the data, or interpreting the raw data in meaningful ways. And this interpreting or this kind of feature learning, this can be handcrafted or this can be automatically learned. Okay. So when it is handcrafted, that is handcrafted in the sense I talk to the the domain expert. Let's say I'm talking about real estate. So I talk to someone who is an expert in real estate. We find out what are the factors important, what are the, based on his experience, what he has seen with the past data. And I try to take that information and I try to transform my data within that format and then learn the model. I would be into the area, when I'm doing that kind of a thing, I would be into the area of shallow learning. Okay. Uh, Deep learning is when I don't even do that, when I don't discuss with the domain expert and I allow my model to learn how to extract features from the data itself. Okay. So even this part where we are not taking help from a domain expert, we are allowing the data itself to, we are allowing the model itself to learn from the data what features are to be extracted. That would be something called as deep learning. Okay. So here towards shallow learning, we have more of human interaction. But towards deep learning, we have less of human interaction. We have more of the machine learning from itself. Okay. So some example is whether we are using domain specific knowledge or not, or we are using data fairly in the raw form, and we are allowing that to train our model. In shallow learning further, we have comparatively less data. So since here we are using human knowledge, so this human knowledge may be taken by years of experience, right? So yeah, let's say I'm trying to make a trading bot that will do algorithm trading, and if I've talked to someone who has been trading for the last 15 years, then that guy will be able to tell me, okay, these are the indicators which are of importance. These are the support and resistance terms, or he'll give you some information which stocks are important, or depending on where is the economy is right now, which sectors will do good. So when we try to incorporate that information, I require less data to train the model because some of my learning has already happened. I'm just trying to fine tune it. But whereas I start with completely raw, okay, I have no information regarding how trading works, and I'm trying to learn everything from my model. In that cases, we require lots and lots of data. So deep learning is basically a field where you require lots of data to train the model. And the primary reason for having lots of data is our models are so complex that to train all of those parameters, it requires huge amounts of data. Whereas here in shallow learning algorithms, our models are not very complex. They are complex, of course, but not as complex as deep learning. So we can do very well with even less amounts of data. That also means that shallow learning algorithms will be much faster to train compared to deep learning algorithms. So deep learning algorithms, we have known it trains for days and months even, whereas shallow learning algorithms, depending on the complexity and the size of the problem, you can do well within hours of training as well. Okay. Shallow learning algorithms or the models here are understandable. So you can look at the model and you can try to see why the model is doing something or why it is predicting an answer based on what it is seeing. Okay. Whereas deep learning models, they are like a black box system. It is very difficult for us to understand why a deep learning model is doing what it is doing. So many of the times, that is another thing that people are researching on. They create complicated models that are able to do very well, and from those models, we are trying to learn what are the decisions the model is taking, so that we can educate humans. We can educate on how to do things and so on. So deep learning models are primarily they are black box. Okay, you cannot understand what is happening inside. Some examples of shallow learning algorithms are KNN, which is like K nearest neighbors, decision trees, naive Bayes, linear regressions, lasso, ridge, etc. So these are examples of shallow learning algorithms. Whereas deep learning algorithms, primarily, they are implemented using deep neural networks. So deep neural networks are networks. Probably in future courses, we'll find out what neural networks are. So deep neural networks and neural networks which has lots of hidden layers. So when they have a lot of hidden layers or deep hidden layers, it is very difficult for us to see what is happening inside. Does that help in answering what is deep learning?
Yeah, Elijah, I have one more doubt.
Yes.
So, for example, how much data is good enough? How much is less and how much is more? Because in our industry, it's like we are trying to implement all these things, but the problem is the data. We need a lot of testing to get data. So, how much
Again,
data is good enough?
even for this question, we cannot have a standard answer. We cannot say like, okay, 1,000 samples are good enough or 10,000 samples are good enough. It will again depend upon the complexity of the problem and what you're trying to learn. Okay. In general, so we can just make you can just make subjective assessments. Shallow learning in general requires less data. Deep learning in general requires more data. Again, even within the deep learning space, what is the task that we are trying to do? So let's say I have a series of images, and these images can be either straight or they are upright or they are sideways. Okay, and my task is just to identify sideways to classify between whether the image is upright or sideways. That is a simple problem to solve compared to I have images of different objects, and within a given image, I want my algorithm to identify if it is seeing a table, if it is seeing a computer, if it is seeing humans, and is it able to differentiate between humans. Okay. Now this would require huge amounts of data because it will exactly have to learn what a table looks like. Okay, to know what a table looks like, it will probably require So again, identifying between a table and a chair is again an easier problem compared to identifying between human beings. Okay, so if I give it,
Robin, just to add to what Ella just said, see, if you really want to have a very accurate algorithm, then your data should be fairly large, because the data actually should cover all the possible boundaries which you cannot even think about. The issue is that the human understanding is quite limited, and we work in certain boundaries. So to identify more permutation combinations, you actually need to have terabytes of data to have a much more accurate result for something like this. Means in general, I'm saying.
so it primarily depends upon what kind of problem you're solving. Okay,
Yeah.
if you have an easy problem, less data will do. If you have a hard problem, you require more data. So easy or hard, again, easy or hard problem depends upon how complex your model is. So as I told you the earlier example, identifying between upright image or a sideways image, it's an easy problem. So you could do so I did an example of training an algorithm where I have photos of dogs and they are either sideways or upright. And my data set consisted of 200 images. And with 200 images, it was able to give an accuracy around 95% or so. Okay, which is pretty good for that kind of problem. But let's say if my task is identifying between images of a cat, dog, a horse, a bird, then 200 images definitely not enough. Okay, I would require images in the order of thousands, maybe even tens of thousands. Okay. Further, to identify whether distinguish between. So let's say you're writing a face identification program for your security system. Okay, that would require probably lakhs of data to know how does a person look like. Right? So again, it all depends upon the type of problem you're trying to solve. How complex is your problem? How complex is your model? More complex the model, more amount of data. It is very difficult to
So the
come with
data,
Yeah. And
so the
just
data includes, yeah, data includes both learning and maturing the model, right? That's what we are referring to, the amount of data, right?
uh,
The
maturing
means,
and learning probably would mean the same thing. Again, the way it would work out is
I mean, improving on the measure.
yeah, one thing you could do is let's say you have X amount of data, you train the model, deploy the model, see how it is doing. Okay. Now based on, let's say it is doing worse than before. Okay. Let's say in the training you assumed that you are getting an accuracy of 70%. When you deploy the model, you are getting 60, and over a period of time that is reducing. Probably that means that I need to improve my model again. So you take all somewhat of, you take the previous data and new data, you bring your model back, you train it again, then you deploy the model. So over a period of time, you're seeing how your model is doing good. Also, let's say your scenario is changing. Okay, then it becomes very difficult, because then you need to have a model that is continuously updating. So again, we cannot have a very a fixed answer to this. It depends upon case to case. Sister was saying something, right?
Yeah, just to
Yeah.
add one practical tip which helps me is, with whatever amount of data you have, you first test the model, see the accuracy, and if you see your accuracy is increasing, or you're getting a decent accuracy, and when you're validating it, the results are good, you can say, okay, I can use this model. It's just a practical tip. Because many times we think before we get into the model, but it is much easier if we just implement the model and then check the accuracy. And one more thing is, our data set, we can split our data set into, this is something that again is practiced widely. We split our data set into train set, test set, and validation set, where we say 70% of the data that I have, I will use it for training my model, and then I'll fit my model on the test set, and then I'll validate it into in my validation set, where I check if my model, whatever results I'm getting, is it going well or not. That's, I think, one more point.
Okay, thank you.
Hi, Raja.
Yes.
Like I have I found something interesting with Google Photos. I think so it's also having a facial recognition. It's like
Right.
it's memorizing all the photos which is having in my in my cloud server, and it's acting. Suppose I have your photo, and it will be showing all your photos of you from
Mhm.
past years or 3 years, from the time like I have been recording your photo.
Right.
So is it with regarding deep learning or shallow learning?
Yeah, it is definitely deep learning. So
It's
because yeah, it is a hard problem. Uh, so just imagine the task of taking an image and identifying who that person is.
Hmm.
How will the computer know what a person is? So the computer can only see pixels. It can see zeros and ones.
Yeah.
So taking that zeros and ones and learning what a straight line is, what a curved surface is, seeing how what curved surface try to constitute a person. I think so. It's a hard problem. It is definitely a deep learning model. And the
Hmm.
way, so I think that's a good example of unsupervised and supervised also. So what it does is, let's say you have probably hundreds of images. It will try to identify different faces, and maybe it does not know the name that is associated with that face, but it will group them together, and it will keep that all of these faces look similar. It does not have a name to it, but they look similar. So that is an unsupervised problem, right?
Oh.
So even when you look at your Google Photos, in the people section, it will identify so many faces, and then
Yeah.
later it's asked that all of these photos look like same. Do you have a name for that? So you can click on it and you can give a name. Once you give
Yes.
a name, and later also, if you remember in Google Photos, it will ask you that is this person the same person? Okay.
Yeah.
So when you're doing that, when you're adding the answer yes or no, you are actually doing supervised learning, where you're training, when you're answering, what is the right answer to this. Once you have the right answer to this, it can have that, it can train the model accordingly.
Okay, but the super fact is like you said, for facial recognition you may need lakhs of photos, but like in the scenario, like
Yes.
maybe two,
Yes. So
two,
I,
two,
I, I, I I understand what you're saying. So here, the scenario is, it does not start from a blank model. Okay. So every time it sees a person, it does not start from a blank model. What Google Photos would have done is, it already has pre-trained models trained on different human images. Okay.
Okay.
So when you have pre-trained model based on different human images, what you're doing is they are taking that pre-trained model and they are repurposing that model for a different task. So this would be something deeper into like going more detailed into deep learning. There's a method called as transfer learning. Okay. A method called as transfer learning, where you start with pre-trained models, and with those pre-trained models, you're just trying to repurpose it for a different task. So maybe later when we have a more detailed discussion on how these algorithms are actually working, we can see how transfer learning works, or how does it, for the same fact, how do other models work. we are probably going to have more sessions based on this, and maybe in future sessions, once you have done basics of Python or once you understand how programming works, we can go into data analytics methods and see how machine learning and other things work.
Okay, thanks, Elijah.
I have one question.
Yes, go on, Agent.
Elijah, here deep learning is a combination of supervised and unsupervised learning, or is it more of unsupervised learning since we have least intervention or least
So supervised or unsupervised is not by is determined by the data that. If our data is labeled, then that is called supervised learning. If our data is not labeled, it is called unsupervised learning. Okay. So deep learning is a method where we have deep neural networks for training. So generally, from my experience, deep learning is a supervised learning kind of problem. It is not an unsupervised learning kind of problem. But you can always state your question in different ways. Okay, to be able to employ deep learning or not. We don't answer based on the algorithm whether it's supervised or not. We answer based on the data that we have. If your data is labeled, then your algorithm will be a supervised model. If your data is unlabeled, then it will be unsupervised.
But a problem actually can have a permutation of both, right?
Yes, to solve a bigger problem, I can have smaller models doing separate things. So like even for solving a labeled data problem, I can have something called as anomaly detection in between. So anomaly detection is an unsupervised, it comes under the unsupervised category, if you see here. Okay. So for solving a bigger supervised problem, so again, rarely you will find a big problem statement where we have used only one of these. You will probably use combinations of different ideas and different things. So depending upon that, you will decide how things are. Okay, I think we are ending, like we are falling short on time. We'll just finish this one slide and then we can take more questions. So now that we have some idea of what data science or AI ML space looks like, if you are new into this field and you want to enter into this world of data science, probably we have to start with learning the basics. Okay, so this is where you primarily look into which languages you will learn. So the major programming languages for machine learning or data science within this space is Python, and then we have R as well. Okay, the major tools that are used in this space is Tableau, Power BI, etc. Okay, you have to learn the basics on what is data handling. How do you access different data sources? How do you merge them? How do you connect them together in one space and doing things like that, data handling. We also learn about data visualization. How do you data visualization is again in the area of descriptive analytics, when you are trying to plot this data into ways which tells you more than the raw data tells you. Okay, so it's the idea of storytelling. Okay, you're taking the data and you're trying to see what is the story that it is trying to predict. You also learn machine learning here. Machine learning is all the different things that we talked about earlier: supervised, unsupervised, classification, regression, reinforcement, deep learning. Okay, so once you know the basics of this space, in the path of going to a job, you would probably now will be a good place to build a data science portfolio. Okay, so data science portfolio would be a place where you will try to showcase what you have learned. Okay, so here the ideal thing to do would be to find data sets that you're passionate about. So let's say you're passionate about music, you can go ahead and so there are publicly available so many data sets around. I can provide you links of where to find data, and we have structured data, we have unstructured data. You've got many universities that provide data. You've got many government websites that provide data. You can look into those data sets. You can try to find a problem that you are really passionate about, and you can solve those problems. Okay. Once you have solved those problems, you can showcase what you're doing on open sources. Like you can put your code on GitHub or Kaggle. GitHub is a common space. I'm sure many of you may already know about it. We have, for data science specifically, we have a website Kaggle where it hosts lots of data, it hosts lots of tutorials, it hosts lots of competitions that you can participate in. So these are places where you would actually showcase your data science skills. Over a period of time, you would develop your portfolio. Okay? You would also you can post on LinkedIn your progresses. If you have solved some problem or you're trying to invite people to collaborate with you, you can post it on LinkedIn. And slowly and steadily, after you have learned the basics, you focus on building a data science portfolio. Once you have done that, or of course, once you are in the process of doing that, you can then transform your resume into the same pattern to show what are the data. This is where your portfolio comes into matter. Right? because your portfolio will basically show what kind of skills you're equipped with. You'll update your resume based on that. You can also map your previous experience. So if you have a previous experience in programming, or you have a previous experience in statistics or maths and things like that, so things that are related with data science, you can map those experiences and you can map this education to your data science skills. You can highlight projects. We can further go on with preparing for interviews. So I have got certain books which gives you like common questions that interviewers ask. So there's a list of 500 questions. You can go over those questions. You can talk about your projects, your data science projects. You can showcase your hard skills and soft skills. And finally, you come to the process where it's a lifelong learning. So no matter how many years, even you are a beginner or you are someone who is experienced with data science, it is always good to continuously upskill, because every every now and then you've got different languages that come up, different ideas, different skills, different toolboxes that come up that can make your work easier. So recently I was hearing there's a language called as Julia. Pasaluk, have you known this?
No, no, I don't
Yeah,
know.
okay. There's a language that is coming.
I know my daughter's name is Julia.
there's a language there's a language that is gaining favor in the data science community called as Julia. So it is being suggested that probably in the years to come, Python, Julia would take over Python also. So we are not sure. So you have to continuously upskill. My point is you have to continuously read. So within reading blogs regarding data science, there are very good blogs like Towards Data Science. There is Analytics Vidya, which continuously talk about what are the different toolboxes, some sample cases, how things work out. You can start reading those. You can start hearing to podcasts. So there's a very good podcast. So if you're starting with machine learning, there's a very good podcast called as OC Devil, Machine Learning 101. So this guy, he speaks on the basics, series of some 20 audio lessons of 20 minutes, 30 minutes each, which gives you the whole space of what machine learning is like. There's a very good advanced podcast, Data Skeptic. This guy is very good. He interviews with major data scientists working for big companies. They talk about different spaces, domains, medical, advertisement, and so on. Further, for your lifelong learning, you continue to work on more projects. You start competing in hackathons or on Kaggle. And once done that, you again go back to the first part. Okay, you again then go start learning basics, try to improve more skills, add more skills, start building the portfolio. So data science journey would look something like this. So if you're someone who is interested into this field, and you should be, and maybe even if not interested, let's say you're not looking for a career in data science, we should at least know what data science looks like, because the way things are going, the future would primarily, there would hardly be any field that will not be influenced by data. Okay, so it's a very good time to invest time and resources into learning or starting this journey. And thankfully, within our group, we have sessions uh, which are catered towards this. We will have probably some sessions based on Python. Python is like a very good point. It's a very easy language to start with. You can even with people with no programming background can very easily learn what Python is. Okay? It is very simple and it is very useful, and it is probably the standard that many companies use. Okay, so you can start learning Python. We'll also have sessions on what are different machine learning algorithms, how do you train algorithms. So we don't have time right now, otherwise I had some more examples on what exactly a machine learning algorithm looks like, how do you train algorithms. I've got certain samples that we can share. So
So
all of this
that
I
will
had
be
in the,
sharing when you take a deeper session on machine learning, right?
yes, I can share. I can actually mail the answers, but it like you would probably be lost. You can find these answers online also, but if there is someone to guide what is happening in the example, it would be much better. So in the next sessions or later sessions, we can schedule that and we can have those sessions as well.
So thank you, Elijah. So all of you are attending this. So what he said, please don't take it lightly. Nowadays, everything is made, decisions are made on analytics, and even your day-to-day life, your finances, everything. You may think it's all nothing. If your finance is in a mess, your credit card, all those things, lot of things you actually can make decision uh, based on analytics. So I would encourage each one of you to really try, including myself. So next, probably we will move from here to learning Python. So Sister Monica will teach us. So Python is I heard it's a very simple English type of language. So at least we will know, because when we hear the word program, it's very difficult to move from there. But Python is something which is very extremely easy to learn. That's what I understand as. But as we go through the journey with Monica, we will know how easy it will be. And nowadays, most of the cloud things like AWS or Azure, they all have inbuilt AI, IoT, analytics, all modules are inbuilt. So it's pretty much everywhere it is there. And so it's something good to learn. And thank you, Elijah. I think it was extremely good session.
Yeah,
Do you
thank
have
you for the
any
opportunity.
do you have any questions? You can put it across so that we can close it in probably in the next 10 minutes. If you have anything further.
Thank you so much, Elijah. That's all I wanted to say.
Okay.
Thank you for listening. Thank you for listening.
Thank you.
Yeah, and one more thing.
Thanks, Elijah.
If any one of you think there is an area where you can contribute, like what Elijah is doing, please reach out to me or Anamika, because we can schedule you as well. Because we are all going to learn each other from each other for next 3 to 6 months during this period. Probably it's a good thing to do at this point.
I just want to add one thing. What Pastor Luke said about Python. I worked one of my project. I really found it very easy, and also I found that it reduces your the size of your file, because I worked on Java, and if suppose something you have to just simply you have to print, you have to create a class, then static void main function, then but simply you just write print and in Python. So basically what I'm trying to say that is really very easy, and it reduces your file size, your project size also.
Anybody has anything, please feel free to share before we close. If you
just a doubt, Pastor. Just not a doubt, as in just a request. Is it possible that we can have? I mean, I know it is not correct to ask, but a small demo or something about with respect to the tool that kind of gives you hands-on, because all these things that we see, these are available in theoretical everywhere. But what we miss actually is a small hands-on or the tool-wise idea.
Okay. So, Manoj, to answer your question, if see, there are a lot of this group is a combination of right? Lot of people from different backgrounds. So this is a very good base to start for all on this particular aspect. So in the future, what we will do is, you want a practical aspect of how this is, right? So probably we will chart out that course about Python, and maybe coming up with the programs and how these things work, algorithms work and all. We will chart it out. Is that whether that should be okay with you?
Yes, Pastor. Yes, Pastor. Just a suggestion or just a request. That's all.
No, we have that in mind, because otherwise this is not just going to end with this one session, because we want this to have a good impact in each one of us who are going to take it seriously. Anybody has anything, please feel free to add. Otherwise, we'll close. So I think that's pretty much. Thanks, guys, for. I think so we'll let you know the continuation of this part on the data science. Otherwise, thanks, Elijah. I think it was a good job. I think I really liked your storyboard, the way you put it. It's easy to visualize things. Yeah.
Thank you, Elijah.
Thank you.
Thank you so much.
Thank you, Elijah. Thank you.
Thank you.
Thank you all for
Thank you
Thank
so
you,
much.
brother.
Thank you.
Bless you so much. Thank you so much.